In the beginning, words we all know. But what exactly happened in the beginning? How did our universe come into being? And just how long has it been here? Science can answer a lot of questions, but can it tell us how everything began? It's our nature to want to know how the universe works, and much of our understanding begins with some essential laws of nature. The law of conservation of mass and energy says that energy can be transformed from one form to another, but it can't be created or destroyed. The law of increasing entropy says everything is in gradual decay, that energy tends to go from a useful form to a useless form. And the law of cause and effect, which says that everything with a beginning has a cause. But science deals only with the observable present. What happened in the past is not something we can test scientifically. We have to take what we know and work backward to the birth of the universe, at the instant of creation, in the beginning. Hi, I'm Marcus Lloyd, and welcome to Unlocking the Mysteries of Genesis. Today we're going to talk about the origin of, well, everything. And we're going to get some help from Sir Isaac Newton. You remember him. He came up with some pretty clever ideas after seeing an apple fall in his orchard. In fact, his ideas were the beginning of modern physics. Newton was born in England in 1642. He was one of the greatest scientific thinkers of all time. He was a modest, unpretentious man and deeply religious. He studied at Cambridge University, where he published important works on mathematics and optics. Among his many contributions, Newton's studies of gravity and mechanics became the foundation for how we understand the universe. His laws describe how mass behaves when acted upon by a force such as gravity. The laws of physics tell us that energy cannot be created or destroyed. Take this block. When I pick it up, it now has potential energy. The energy comes from Earth's gravity wanting to pull it back. If I drop it, the block is in motion. The potential energy becomes what we call kinetic energy, the energy of motion. It's the first law of thermodynamics. Energy cannot be created or destroyed, just converted to another form. When it hits the counter, the energy changes again to sound and heat this time. But it's still energy. It's the same amount that the block had when it was falling. It's just taken on a different form. You can see it here too. As the energy is transferred, some of it becomes sound and heat. So even though the amount of energy in the universe is constant, the quality is constantly running down, much the way these metal balls slowly lose kinetic energy. This is the law of increasing entropy. Same with the wood block. All that energy it got from gravity still exists, but it exists in a different form. The energy transforms into sound and heat, and it doesn't do the block much good. The energy available for useful work has decreased, just as it is decreasing for the whole universe. Which leads us to the third principle, the law of cause and effect. This block isn't going to move again unless I move it. Cause, effect. So you're thinking, well, that's good, but what does that have to do with the origin of the universe? Well, come with me. We're about to find out. Our concept of the universe has expanded dramatically in the modern age. thanks in part to powerful telescopes like this one. Our understanding advances with technology as more and more tools are becoming available to astronomers and physicists, people like Georges Lemaitre, a mathematician and Catholic priest from Belgium. In 1927, he published a scientific paper that didn't get a lot of attention at the time. In it, he explained the relation between the distances and the speed of movements of galaxies. He made a case for an expanding universe and showed how space itself could be expanding, carrying galaxies further outward. Now, about this time, an American scientist, Edwin Hubble, was using the Mount Wilson Observatory to measure the distances between galaxies. Hubble's observations revealed evidence that Lemaitre and others were correct. The galaxies seemed to be moving further away from each other. Lemaitre suggested that if the universe was expanding, then it must have been smaller at its formation. He proposed that everything began at one moment in time. Then he took the idea of an expanding universe and worked backwards in time to a point when everything would have been squeezed into a single particle, what he called the primeval atom. When this particle exploded, he theorized that it created everything, all space and time, in what secular scientists now call the Big Bang.
The Big Bang is the most common secular idea for how the universe began and how it came to be the way that it is today. Basically, the view is that the universe started as a point, a singularity. All the mass, all the galaxies, everything that would become galaxies was in that point. Even space itself is allegedly contained in that point. And then that point rapidly expands, carrying out energy with it. Now, some of that energy turns into matter, basically. It becomes hydrogen and helium gas, which then turns into stars and galaxies and so on. And this basically is the secular idea of how the universe came to be.
But what evidence do the secular scientists offer to support their ideas? The universe, as we know it, has over 100 billion galaxies, each with billions of stars. According to the Big Bang Theory, as the universe expanded after the primeval explosion, its energy cooled and became microwave radiation. In the 1960s, scientists detected microwave radiation coming from all directions in space, a cosmic microwave background, or CMB. Could this be the afterglow of the Big Bang? Many physicists accepted the CMB as compelling evidence for the Big Bang Theory. NASA has launched satellites to study this microwave background radiation. The most recent was the Planck satellite, launched in 2009. The Big Bang assumes that there would have been hot spots and cold spots in the early universe. These should still be visible today as substantial variations in the temperature of the CMB. It's ironic that Big Bang scientists consider this microwave radiation to be one of the strongest arguments for the model. They think of it as a successful prediction. But the CMB is much more uniform than Big Bang supporters had originally predicted, and has only subtle variations in temperature. Planck also revealed some other surprises. Although the tiny fluctuations in the CMB are supposed to be similar in every direction, they are not evenly distributed. The data seem to suggest a special direction in space, contrary to the predictions of the Big Bang. What this means is that improved measurements of this radiation may actually be challenging the Big Bang rather than confirming it. Let's see what scientists have to say about this.
What we found is that the cosmic microwave background is very uniform, with very small hot spots and cold spots, 100 times smaller than what the Big Bang supporters were expecting. So really, it's not the right kind of cosmic microwave background to support the secular model. Now, the way that Big Bang supporters have tried to deal with the very uniform nature of the cosmic microwave background, which was not predicted in the Big Bang, is they've invoked what they call inflation, or cosmic inflation. And it's the idea that the universe basically, when it started expanding. It then suddenly expanded at a much faster rate, the inflation phase, and then it dropped off to that slower rate afterwards. And this could alleviate what we call the horizon problem, the fact that you find these very smooth temperatures throughout the universe. What's interesting is that secularists tend to hold to a uniformitarianism philosophy, the idea that rates and conditions are basically constant. Inflation really is a violation of that principle, because it says the universe suddenly expands at an accelerated rate and then drops down to its regular rate and so on. And that really is a violation of that very uniformitarian principle. So it's interesting that secularists have had to violate their principle in order to save their principle, which is inherently contradictory.
Well, when we look up at the sky, our instruments can detect this radiation, this very uniform electromagnetic radiation that's coming to us from all directions in space. And the peak intensity of this radiation is in the microwave part of the electromagnetic spectrum. That's why they call it microwave background radiation. Now, the secular cosmologists interpret this as this relic, leftover radiation from a time about 400,000 years after the Big Bang. And in fairness to them, they did predict that there would be this afterglow, if you will, from the Big Bang. And so they consider this to be one of their strongest arguments for the Big Bang. But what's interesting is we get better data, better measurements of this background radiation. It's actually starting to cause them some headaches. One of the reasons for this is that one of the fundamental assumptions of the Big Bang is something called isotropy. And that means that any direction in the sky should be the same as any other direction. In other words, if I look at the background radiation over here or over here, we really shouldn't see any large-scale differences. Well, it turns out we do see some subtle differences in different directions when we look at that radiation.
So, was the universe formed by a Big Bang, or is it God's creation? If it all began by random chance, in a giant explosion, it seems we would expect to find pure chaos around us. Think of the most powerful natural phenomenon we can observe today. Events like tornadoes and hurricanes. They leave behind destruction and disorder. But our universe shows exquisite order and precision. We don't have to look any further than the sun. Gravity keeps the sun's hydrogen together, creating the intense pressure that leads to nuclear fusion in the solar core. There, hydrogen nuclei fuse into helium and release energy, the energy that keeps our planet alive. With all that explosive energy, you'd think the sun would destroy itself, but it doesn't. The laws of physics holds it together. The high temperature of the sun creates pressure that pushes outward on its layers of gas. But the force of gravity pulls inward on these layers. These two forces are exactly balanced, resulting in a stable sun. This, and not random chance, is what keeps billions of stars burning in billions of galaxies. The laws of physics describe the way that atoms and molecules are held together. If these laws were changed even slightly, atoms and molecules would not exist, and life would be impossible. This beautiful order and precision points to a plan, a moment of divine creation. There's evidence for it all through the cosmos.
A galaxy is a collection of millions to perhaps trillions of stars. And there are several different types of galaxies. We have these big elliptical galaxies, we have dwarf ellipticals, but one of the most common types is a spiral galaxy. These tend to have a disc shaped with a bulge in the center, and the disc tends to have spiral arms. The stars are organized into these beautiful spiral arms that you see in some of these grand design galaxies. Now, the interesting thing about spiral galaxies is that they rotate differentially, which means the inner portions rotate quicker than the outer portions. So the inner portions are doing this, the outer portions are doing that, which means that spiral structure is constantly twisting tighter and tighter. It's called the spiral winding problem, but it's only a problem in the secular view, because if the galaxies really were billions of years old, they would be twisted beyond recognition. But they aren't. We find spiral galaxies all throughout the universe, and so that's a suggestion that they're not anywhere near their alleged secular age of 10 billion years or so. They must be much younger than that. Blue stars are also an indication of the youth of the universe. You see, blue stars are some of the most massive, most luminous stars that exist. They expend their fuel at an incredibly rapid rate. Even though they have a lot of fuel available, they're very massive, they burn it up very quickly. It's kind of like an SUV. They've got a big gas tank, but they get very poor gas mileage. And for that reason, they cannot last hundreds of millions of years. In fact, the hottest, bluest stars, even secular astronomers will acknowledge, they can't last even a million years, some of these. And yet we find them all throughout the universe, a universe that's allegedly 13.8 billion years old. Some people have asked, well, why can't we just say that God created over billions of years and whatnot? Why does this really matter that the universe is young?
And when you look at the Big Bang model, it's part of this overall evolutionary story where you have death and suffering going on for hundreds of millions of years on this planet, supposedly before man was even appeared on the face of the earth. So, how do you reconcile that with God's love for his creation?
There are a lot of different lines of scientific evidence that confirm that the Bible really is what it claims to be. It really is the Word of God. We've seen that when the Bible talks about life, animals reproducing according to their kind, well, that's exactly what we observe in the world. When the Bible touches on astronomy and it talks about the circular nature of the earth or what have you, we find that's exactly what we observe in the world. The Bible's right in all these issues. You see, the reason that science works is because God upholds the universe in a consistent and uniform way, and he does that for our benefit so that we can understand it and write down equations that describe how God upholds the universe. Equations like E equals mc squared, for example. Now, how would that be if the universe were just a chance accident? Why would it be that it obeys these nice, neat little equations that we can write down? Why would the human mind be able to understand those equations? And so you see, my question is, how would science even be possible apart from the Christian worldview with creation at its foundation? It's interesting that my secular colleagues try to use science to discredit Scripture sometimes and say, well, we think the science leads us toward an evolutionary notion, but it seems to me that if evolution were true, there'd be no reason to trust the methods of science in the first place. The Bible alone makes knowledge possible, and I haven't seen any secular worldview that can do that.